day, fellas, it's always back. Today we are going to do some isotope. To be specific, to calculate the relative atomic mass. When let's say they give you two isotopes. But firstly, what I'm going to do with you is, let us consider the term isotope. I want us to visualize these two atoms, chlorine 17, or let me write an atomic number here on top, 17, when we have 35, and here we have 37. Look at these two atoms. We have the atomic number here. This is our atomic number. We also have the atomic mass for each. If you can clearly look at these two, we have the first one and we also have the second one. The atomic number is the same for both, but if you look at the atomic mass, it's not the same. Then now the definition of isotope will be an atom with same atomic mass, atomic number. You see we have 17 in both, but different atomic mass. See, this is the simple definition of what? Of isotope. Now what I'm going to do is I want us to do some calculations of relative atomic mass. You see, the relative atomic mass, or the average of atomic mass. Let me take my periodic table. Look at the chlorine there. We have an atomic mass of 35,5. Sorry, in fact, this is a relative atomic mass. It's not the atomic mass of chlorine. It's a relative atomic mass. Somehow it's an average of more than one chlorine. You see, it's like in this case we have two of them. You see, we have the first one and we also have the second one. Then we must calculate what now? The relative atomic mass, the average atomic mass of what? Of these two. Let's say if the first one, it constitutes of 75,5% in a relative atomic mass. And now let's say if this one consists, or it constitutes of 24,5%. See, then the questions that we must do now, we must calculate the relative atomic mass for the first one as well as the second one. How are we then going to do the calculations of these given isotopes? It's so simple. we are going to need firstly the atomic mass of each. Then we are going to multiply those with what? With their percentages. You see, with their percentages. What I'm going to do now, firstly, let us divide those percentages with 100. It's like I have, for the first one, I have 75,5 divided by 100. If I divide this number by 100 clearly, we do have our calculator. 75,5 divided by 100, we get 0.755. Let me do the same for this one as well, which is 24,5 divided by 100. If we divide this number by 100 clearly, we are going to get 0.245. You see? Then now, immediately after converting your decimals like this, we can then calculate the relative atomic mass. The relative atomic mass. We are going to say now the atomic mass of the first one, which is 35, then we multiply it by its percentage, which is going to be now 0.755, plus we take the atomic mass of the second one, which is 37, multiply by 0.245. Yeah, then we can then use our calculator, which is going to be now 35 multiplied by 0.755 plus 37 multiplied by 0.245. We get, let us round our answer to 2 decimal places. You see, it's going to be, to 1 decimal. We got 49. Let us round it to 1 decimal, which is going to be 0.5. Then the units can say see, do you still remember from our periodic table that our relative atomic mass was 35.5? You see, this is how we determine the relative atomic mass when it is given, let's say, 2 isotopes or even more. You can just continue by adding the product of atomic mass together with its percentage and calculate. It's simple as like this. I thank you, fellas.